Hello and welcome to Future Building. I'm Mathew Aitchison and I'm Professor at Monash University and CEO of Building 4.0 CRC. In this podcast, we take a broad look at buildings and building in contemporary society and what's coming down the pipeline in the future. We'll talk with invited guests and experts in the field, where we'll cover news and trends along with research and developments in the industry. Future Building is proudly sponsored by Building 4.0 CRC. I first met Ray Levitt as part of a knowledge share that my group had organised at Stanford University in February 2024. We were there to learn more about the world-famous innovation ecosystem that is Silicon Valley and, of course, Stanford. And who better to induct us into this world than Ray Levitt, Emeritus Professor at Stanford University and operating partner of the VC firm Blackhorn Ventures. Ray didn't just speak to our group that day about Stanford, where he'd worked for several decades, and its interplay with venture capital firms in Silicon Valley, but he also spoke about the various startups that were in the room. Through his work with Stanford and Blackhorn, Ray has advised countless entrepreneurs and startups and has an unrivaled breadth and depth of insight into the built environment. It was clear to our group that almost all the companies had crossed Ray's path at some point or other. Ray's knowledge, his command of the issues, his insights into the opportunities and barriers in the industry is impressive, and that's to say the least. A little bit more about Ray. Dr. Ray Levitt is Emeritus Professor at Stanford University. Ray completed his PhD at Stanford in 1975. He was also briefly entertaining the idea of working at MIT before he returned to Stanford and became a member of faculty in 1980, retiring much later in 2017. Ray started in the civil engineering department and founded a group called Global Project Center, which focused on finance structures for big projects. And he went on to run a course at Stanford for students interested in entrepreneurship entitled Venture Creation for the Real Economy. In line with this entrepreneurship theme, Ray is a longtime member and the current president of the Farmers Investment Club, which is an angel investment group made up of Stanford faculty, staff, and affiliates. Little wonder then that in his post-Stanford life, Ray moved towards VC, where he became an operating partner at Blackhorn Ventures, and where he advises startups and scale-ups with a specialization in built environment. Ray, as you can imagine, holds numerous titles and distinctions. He became a distinguished member of the American Society of Civil Engineers in 2008 and was inducted into the National Academy of Construction in 2013. Just a few nuggets from our talk today include Ray's view on the reasons for the demise of Katerra and why it's hard to raise large sums of money at the moment in Silicon Valley for capital-heavy ventures. The idea that we're in a transition phase of technology in the industry where larger firms are consolidating their market offerings through strategic acquisitions, or why Ray is an AI optimist for the industry, but not for the startups in his portfolio. I really hope you enjoy this interview as much as I did. Spoke with Ray from his home studio in March 2025. Ray, welcome to the show.
Thank you.
Ray, we've obviously heard quite a bit about you in the introduction, but I wanted to start a little bit with your background and how you came to be where you are. Obviously, that starts at Stanford. You did your PhD at Stanford. I believe you completed that in around 1975, and then you started at the civil engineering department around 1980. You started a center called the Global Project Center. I was just wondering if you could tell us a little bit about that center and what you were trying to achieve there.
Okay, and just one other bit of background. Between 75 and 80, I was on the faculty of MIT, which was trying to launch a construction management program.
Okay.
It turned out it wasn't finding a happy home in the engineering school at MIT. And then Stanford had a position in 1980, so I moved to Stanford where I had done my PhD. And was happy to do that and found wonderful colleagues both in computer science and social science to work with. And the Global Project Center was really the social science part of my collaboration. The early part of my collaboration at Stanford was with computer scientists building initial AI applications, and then organization simulation modeling, and in the process of that, launched a few startup companies. And so the Global Project Center was focused around initially international construction projects where people with different cultures and beliefs and ways of behaving on projects were having problems understanding and even fighting with each other. And so we ended up looking at U.S.-Japanese joint ventures, which had had quite a lot of problems in the past. We looked at some other Scandinavian, Korean, Chinese projects. We looked at the difference between Taiwan and China, the way they organize projects based on the history of the construction sectors in those two countries, where Taiwan it was national railroads and China it was very different. And then we finally started to look at public-private partnerships, which is really the second part of what the Global Project Center focused on, and how you could build relational contracts that would survive the kinds of risks and the difference between, again, public sector culture and private sector culture and behavior. And we published one book in each of those two areas, one on international, cross-national kinds of projects, and then one on cross-sectoral projects, public-private. As part of that, I actually spent a very informative period in Australia visiting with colleagues in Brisbane, actually, at Ross Israel's group, which you might know, the QIC, Queensland Investment Corporation, that's what it was. You know, they introduced me to people all over the country, including in Sydney and in Melbourne. I had a wonderful tour of Eastern Australia, talking to people who had actually done all kinds of projects, ports, airports, hospitals, roads, mass transit, railroads, and learned a great deal. Australia was one of the more advanced practitioners of these public-private partnership projects and really had a pretty good business model.
And was that very different to what was going on the West Coast at that time?
Well, there was very little in the U.S. at that time. This was 2002. We started doing that work. And again, Australia had had multiple projects by then. The UK had had quite a few, but I think the Australian ones were, in general, not uniformly, but in general, more successful. And so it was really a learning experience that was very exciting. Brought back a lot of those ideas, and we ran that center until 2017 when I retired, so almost 20 years.
Wow, 20 years. That's great. Of course, and this is where we head in today's interview, Ray, towards the venture world. Crawling through the available data, I discovered a course that you created called Venture Creation for the Real Economy, on which the title of today's podcast leans. Could you tell us a little bit about that and what companies came out of it and what was behind that?
So Stanford was one of the first universities to really start teaching, how to create and grow a startup. There was a course developed about 30 years ago, not in my department, which was civil and environmental engineering, but in a graduate school department called Management Science and Engineering. And the person who developed that course, Mike Lyons, had been running it for about 20 years when I met him about 10 years ago. And he agreed to help me launch a similar course for the civil engineering department for people who wanted to do construction tech startups, because a lot of our graduate students had decided after catching the Stanford startup virus, which is perhaps more infectious than COVID, that they wanted to do startups. They didn't want to take a job with a contract of being a project engineer, or they had already done that before coming to graduate school, and what they really wanted to do was launch a construction tech company. So Mike helped me launch this course. The original course had literally hundreds of startups come out of it, including Skybox, which was one of the first satellite camera, data downloading to Earth projects that, is now outshone by Starlink and things like that. But Mike and another colleague, Pedram Mokrian, who had been an investor at Mayfield Ventures, one of the local venture firms, and I launched this course at Stanford. And the first company to come right out of the class was PlanGrid, which you may know was eventually sold to Autodesk for what in today's money would be $1 billion. It was 875 million
Wow.
about 7 or 8 years ago. And and then since then, a number of other companies, Rumbix, which does time cards and time and material tracking and productivity tracking on smartphones, and a number of others, Aurora Solar, which was the front end configuration of rooftop solar for solar installers on residential property. So there've been probably half a dozen. Kit Switch is another one. Scope Zero, which measures Scope 3 outputs and helps companies launch the equivalent of like 401k programs, but savings accounts that people can use to improve the energy efficiency of their homes and their vehicles. And so we've had quite a few successful startups come out of the class already. We've been teaching it now for about 8 years. This is the 8th year. In fact, we're having our final presentations this week on Thursday
Wow.
of 16 different startups.
That's fantastic, Ray. I'm extremely jealous.
Well, I said one of the reasons that I was interested to do this was I had, by that time, launched 3 software startups with graduate students and others, and had, made all the mistakes that I could help other people avoid making. That encouraged me to actually launch this course with Mike and Pedram, and it's been a lot of fun. And as I say, we've had some classes where successful companies come out of the class.
That's great. Well, you allude to the startup virus that is clearly endemic to Silicon Valley and not least Stanford. It takes me to my next question about the Farmers Investment Club. Ray, can you tell us a little bit about that?
So that is a very old institution at Stanford. A number of faculty got together early on. I'm talking the 1950s, and launched a stock buying club where they were buying public stocks, but there were people who really were involved in semiconductor development, and they had really good information about companies like Intel and Sun Microsystems, Silicon Graphics. So they made successful public investments, but I mean, in some ways, anybody can do that. And then about 15 years ago, 12, 15 years ago, a number of younger people came in, including me. And, you had to buy a membership share. It's 20 members. And when one retires or passes away, then they invite another person to join. And you basically buy that person's share of the portfolio. And so I joined and a few other people joined, and we were saying, why are we investing in public companies? There are these fabulous startups coming out of Stanford and Berkeley and many other schools, and we could make super early stage small investments, and some of them might pay off very well. So in addition to the PlanGrid, which was the one that came out of the class, once they graduated, I didn't have any more conflict of interest, so I personally invested, and the farmers invested, and it's one of the best investments I ever made. We got back 40 or 50 times our money from that. And then
Wow.
and then we invested in another one, Aurora Solar, which was even more successful. So from the time we've started investing in public companies, we've had an IRR of about 80%. So it's been a very successful, early, very super early, what I would call micro angel investment group. We do 2 pitches a month, and we screen pitches for interest by the members, and then we pick 2 to hear every month. We meet once a month, and we make tiny investments, and any individual member can co-invest pari passu on the same terms as the farmers if they want to. And for my sins, I'm now the president of that group for encouraging them to go into private investments rather than public investments. So that's what the
Wow.
farmers is. So it's still a club of people who have some connection to Stanford. They're either graduates or they're faculty members or they're staff members. The head of Stanford's Building and Lands Committee is one of the members. And
Yeah.
anyway, that's what it is. But it's a fun group because we do minimal due diligence. We take a 30-minute pitch and then we decide we like the team and the idea, and we 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 throw a small amount of money in, and in a few cases when you play the large numbers game, some of them are going to pan out. I won't brag about some of the really bad ones we invested in, but I'll tell you over a beer sometime.
That would be great. Well, you might get a few more pitches coming from other parts of the world after this podcast,
But
Ray.
this is
Um,
really early stage. This is like some of these people haven't even formed a company yet and don't have a bank account. We have to tell them how to do that.
Wow. Early stage indeed, and that is what you would call very minimal due diligence. I believe there's also a little inside joke in the name Farmers Investment Club. Do you want to just bring our listeners in on the joke a little bit
Well,
there,
it's
Ray?
it's not really a joke. Stanford was originally two Spanish land grants granted by the Spanish government from Mexico to the Spanish um, padres and soldiers who came up to California to try and colonize it for Spain. But after the Mexican-American War, those land grants were not worth very much. So Leland Stanford, who was the president of who was the founder of Stanford, bought two of these Spanish land grants and actually did set up a trotting horse farm. And that farm, by the way, was where the first photo was taken, or set of photos that proved that horses have all 4 feet come off the ground when they're galloping. This was Edward Muybridge, who set up
Oh, yeah.
50 cameras with tripwires and caught the horse with all 4 feet off the ground. But this was a trotting horse farm where they raised champion trotting horses. And then when their son died on a tour of Europe, they only had Stanford's had one child, Leland Stanford Jr. They converted the trotting horse farm into a university. They founded a university in the memory of their son. And so Stanford is often called the farm. It's quite spread out and it's low rise, as you know, Matthew, you've been here. And
Yep.
we have actually a total of over 10,000 acres, of which 2,000 is developed as the campus, again, in a low rise, 3-story maximum, except for a few student residences. And then we have about 8,000 acres of open space. And so it really feels rural. And there's an arboretum between us and Palo Alto. So you really feel like you're not really part of a city, although you're very
Yeah.
close and surrounded by one.
It is quite a unique environment. I can attest to that, having walked all over the campus and its surrounds, and you really do still get a feel for what it must have been like to be a farm back in the day. Ray, moving now to the present and Blackhorn Ventures. You're an operating partner at Blackhorn.
Right.
I wondered if you could introduce to our audience what is Blackhorn Ventures' mandate, what areas do you invest in, and can you also give us a feel for the kind of companies you invest in and your area of specialization
Yeah. Yes.
itself?
So I had decided to retire from Stanford in 2017. Stanford has no maximum age. You can stay employed until you drop if you choose to, but I had had enough of that. And so I decided to retire in 2017, right at the time when Blackhorn was launching its first seed fund. And actually,
Hmm.
one of the founders of Blackhorn was a judge for our entrepreneurship course, which was going at that time. And he said to me after the pitch, would you have any interest in, joining us as a partner to help us invest in the construction tech space? Because we see that as one of the industries that was late to digitize and has a lot of greenhouse gas emissions. So you could help us do well by doing good because we'll invest in things that have a decarbonization or workforce enablement kind of screen on them. And I liked the partners. I met them, and so I decided to join Blackhorn actually during a 2-year period when I was phasing out from Stanford. The retirement plan I took, you go half time for 2 years and then you're out. So I joined
Yeah.
Blackhorn thinking it could permanently be a 50% time job, and I was deluded because it turns out it really became a very full-time job. We made more than 20 construction tech investments. And I should mention we invest in 4 industrial sectors, all of which have this property that they were late to digitize because they had mobile workers. And they were also massive greenhouse gas emitters. So it was the built environment, so design, construction, and property tech. That was my area. And then we have transportation, and again, not so much cars, but more software to make truck pelotons work together and various other kinds of things like that. Um, EV charging. So energy is the third area we invest in. And if you think about something like EV charging, it's right at the intersection between built environment, energy, and transportation,
Hmm.
which, by the way, we find a lot of our deals at the convergence of these sectors. The fourth one being supply chain. And even before COVID, but especially during and after COVID, supply chain is a real issue. And with Donald Trump's tariff shenanigans, it's even more of an issue now, where people
Yeah.
have to figure out, how to avoid tariffs or what they could onshore that's being outshored right now. But in any case, Blackhorn invests in these four industrial sectors at seed stage initially, and then we launched an A round fund about 2 years later with separate limited partners, which was a mistake because some of the deals fell in the cracks between seed and A round, and we had to arm wrestle to see whose portfolio it should go in. And so the third fund we created in 2023 is a combination seed and A round fund. And that's the fund we're currently investing out of. We've almost fully invested out of that fund. We'll do up to about 1 million in seed funds and up in seed companies rather, and up to about 5 in A round stage companies, which already are beyond pilots and have contracts and possibly even some contracts renewing, approaching revenues in the 2 million per year range annual recurring revenue.
Mhm.
And
Great.
we have been different than a lot of other VCs who only invest in pure software. We're willing to invest in hardware as long as it's very capital efficient. And so we have a number of different ways to think about that. My favorite one is to look for very capital efficient prefabrication companies because there are so many tailwinds driving prefabrication and construction right now. First one being the severe shortage of skilled workers for the industry. And with the deportation of Mexican and other Central American workers at the moment, the labor shortage is going to get even worse. And so that's one of the tailwinds. The other one is the high interest rates, which mean that speed is very valuable to the developers of projects. So if you can speed up a project by prefabricating components, that's extremely valuable to the owner of the project. And then the third one is just the evolution of both um, robotics and software to the point where you can buy off-the-shelf robots, customize them with software, even possibly AI or other kinds of software and then custom end effectors to do different things. But the trick is to keep it really capital efficient. So it's the antithesis of the Katera kind of business model where you
Hmm.
take hundreds of millions of investment. We're looking at prefabrication setups that can cost maybe $2 to $5 million maximum to get set up, and then can crank out product with high gross margins that are 10 times that even in a year.
Wow.
So we look at
Uh,
rebar cage prefabrication. We look at
yeah.
interior sheet metal framing prefabrication. So those are two companies we've invested in. And then in the sort of manufacturing automation supply chain area, we've got companies that have come up with clever business models to finance the robots with money other than venture money. And then the venture capital part is the software and the go-to-market part of that. But the hardware is financed by equipment debt or
Mm.
by other kinds of debt associated with the long-term contracts you have with credit-worthy customers. And so again, one of the things I think Blackhorn has gotten good at is investing in things that could be capital intensive, but not financing most of the capital with venture money, which
Yeah.
is the most expensive money a founder can take.
I want to come back to some of those issues that you raised there, Ray, around software, hardware, appropriateness of VC for those types of ventures. But before we get there, I want to just zoom out a little. You mentioned some of the impetus for you to join Blackhorn were around the workforce issues and also issues around decarbonisation. If we zoom out a little further yet and look at the building industry comprising construction, design, property industries, as you were outlining, we'd have to say that the industry has been slow to innovate. You mentioned some of the big failures like Katerra that we're obviously all aware of. It's an interesting sector insofar as there are very few what we would call household names. There's very little concentration, if you like, around um, investment in building innovation. I've also heard some others refer to this area of building construction property as being the last great white space of innovation in the global economy. So I'm really interested at this high level to get your opinion on why has it been hard to innovate in building?
Well, you may have seen the graph that, shows construction productivity flat for 50 years while industries like semiconductors and cars and airplanes and other things are, raising the worker productivity dramatically. And the thing about construction, historically, one of the reasons it didn't innovate is it's a craft-based industry, and craft traditions go
Mhm.
from father to son, literally historically, where there were no women trade workers in the industry, and now it is a little more gender diverse. But the firms were small, they were lightly capitalized, and the fundamental thing that's different about construction that I think a lot of people fail to grasp is that the demand in this industry is very lumpy, it's very unpredictable. It's often subject to delay. Projects get delayed for all kinds of reasons. And so, any kind of software or hardware that is trying to innovate in this industry ends up, sitting idle at times in between big projects and then overwhelmed when too many big projects come in at the same time. And so I think Michael Marks, who had previously worked in electronic manufacturing, didn't quite grasp how challenging that would be for a company like Katerra. I said to Michael when he was starting Katerra, Michael, do you understand that this industry has very, very unpredictable, very spiky demand? He said, we think we can deal with that by bulk purchasing in China. And, he thought he had some ideas for dealing with that. But that has been the demise of all the capital heavy attempts to prefabricate in the past. The other thing that made it difficult for construction to adopt information technology was that mobile workers running up and down stairs and projects, could not use computers because a laptop was useless. You couldn't carry it around on a project. If you did, it wasn't connected to anything. And so you really needed mobile phones, tablets, and broadband of one kind or another, Wi-Fi, WiMAX, and now cellular, before you could really reliably use technology on in the field on construction projects. In the home office, people, bought ERP systems and they did other things, but it didn't help with field productivity. And of course, now with the combination of very powerful smartphones and tablets and cellular broadband and 5G available in many parts of the world, it's possible to do a lot more. And, I see the industry innovating quite quickly now. It's a
Hmm.
difficult market to sell into because I sometimes talk about it as it's not a mom and pop industry, it's a mom or pop industry. Turns out half the companies in construction have in the US have zero employees. It's just a founder with a wheelbarrow, or a pickup truck. And then you have, 400 companies that these days are doing revenues above 200 million a year with very small margins. The margins for general contractors are like supermarket margins. It's low single digit percentage. The subcontractors usually have better margins, but they tend to go out of business and are less stable sometimes. And so it's the combination of the very spiky, lumpy demand, the difficulty of using computers on site until maybe 15 years ago, and um, and just the fact that there are lots and lots. There's a long tail of very small firms, and there's a few hundred large firms who could be $100,000 a year customers. So the cost of selling is high, and so you have to sell big deals to big companies to really make it in this industry. There are very few examples of a sort of a B to C or B to little b business model that have been successful in this industry.
Are there any, Ray, that would jump out at you that you might point out to our audience, perhaps we haven't heard of, that have made that?
There's a company we know of which is training, providing training for workers that they hire then, and then they sell those workers out to installers of energy upgrading for residential. And so this would be things like putting rooftop solar on a house or exchanging a furnace for a heat pump,
Mhm.
putting a heat pump in place of an old gas or oil furnace. And so they train the workers and then they job shop them out to small builders, who are happy to hire these people because they're hard to find and hard for a small firm to justify training. And so that's the kind of thing that works, at scale with small
Yeah,
companies. There's software that helps residential remodeling people, very small businesses, scope their jobs and invoice their jobs and track it. And, we've had modifications done on our house, some of them, significant, over $100,000. And basically it was a contractor with a few of his tried and true subcontractors. And his wife was the bookkeeper. And,
hmm,
that was the business. And so for someone like that, you might be able to sell software at a modest price. But again, the cost of sales of reaching all these small people scattered all over the place is pretty significant. It's maybe a little easier with social media now to find places where these people can be reached online, but it's a challenge. And so it's typically selling to a project or two and then hoping to get a regional license, once several projects adopt something and they think it works. And so with a company like Turner, which has something over 23 divisions, I think they're up to 25 now. You sell to one division and then maybe another division, you work your way up. And at the end of 2 or 3 years, maybe you get an enterprise license. And in the
yeah,
meantime, you're selling project by project. And there are very few solutions that are so obviously attractive at the enterprise level that companies adopt them at the corporate level and require all projects to use them. There are a few.
yeah.
Rumbix was
There are
one
a few.
for time
Yeah.
cards where companies try it out and then decide, all of our projects need to use this. But not very many of those.
Ray, our research has shown when looking at particularly home builders that they often tend to have a fairly deep tech stack. In some cases, scores of different applications that a small company might be using to just get its basic work done, everything from email to Excel onto some of the platforms that you were mentioning then. It raises for me the question of how do we address and how do you, more importantly, with Blackhorn Ventures, address these systemic issues, the small scale of the industry and the cyclic nature of its demand. How do you judge scale of the companies and of the ventures that are starting? In some cases, I've been aware that it can feel a venture is too small or a venture is too big. Um, I would say, for example, one of the reasons that Katera failed, not the only one, and certainly perhaps not the major one, but it set as its task a very, very large task that was always going to be very difficult to solve. Expanding product lines, expanding the jurisdiction where it was working across the entire USA in one fell swoop strikes me as too large. But then when we see some of the smaller, particularly software-based uh, ventures, they strike me as too small to really make a difference to some of the bottom line issues. How do you feel about that portrayal? And how does Blackhorn navigate these issues?
I think one of the challenges that Katera undertook was they tried to integrate the whole value chain from real estate developers, design, construction, or manufacturing, prefab manufacturing, and construction and building software tools to support especially the manufacturing automation. And so if you integrate the whole value chain and the demand is lumpy, it's sort of like, a deer or a kangaroo going through a python where, it's very lumpy in one place and it's empty in another place. And so how do
Mhm.
you keep that value chain operating anywhere near capacity when the demand is so unpredictable and so slow and subject to delay and interruption? And so the the trick with big solutions is you could argue that some of the low hanging fruit has been already taken off the tree. The idea of digitizing blueprints and digitizing construction
Mhm.
documents, there's several companies doing that. That space is pretty crowded between Autodesk Cloud and or AutoCAD Construction Cloud and um, Procore and some of the others. But
Mhm.
with AI, I think there are a lot of opportunities to really create industry-wide solutions that are really good. And so the kinds of things we have looked at are things that go beyond digitizing paper workflows, digitizing data and old paper-based workflows to speed them up and make them less prone to input error by humans. Um, and what we look for now is something that makes more of a difference than that. So, for example, I think I may have mentioned to you in the past a company, Ko-Fi, we invested in. So they started out digitizing the documents that are used for monthly progress payment reports by contractors. And so a contractor will collect these, monthly requisitions from all of the subcontractors for the work they claim they finished that month. And the GC will inspect all of that before they accept it. And then they'll pass on an integrated package with everybody's um, invoices and documents and in the United States we have a mechanics lien law. You have to release the lien so that the subcontractor can't go after the owner for that money again in the future if they get paid for the
Mhm.
work they've done. And so they started digitizing all of those documents and they offered this as a service to banks. So banks were paying them for just packaging all of these digital documents. And then they started to manage human inspectors on behalf of all of the different players. So for the GCs to inspect the subs, for the owner to inspect the prime contractors and all of the work on site, and then for the bank to inspect everybody before they release the construction loan. So if they have to foreclose, there'll be enough value in place to finish the job. And
Mhm.
so they were basically managing a group of outsourced human inspectors. And then during COVID, human inspectors were either not able or not willing to go onto projects. And we talked about it, and I said to them, I wonder if you could use 3D camera images because they could be geo-stamped and time-stamped. And so they asked all of the parties during COVID, and people said, "Yeah, let's try it." So they partnered with a company called OpenSpace, which has a solution that inputs 3D camera images and then analyzes them to identify objects, and beginning to have some AI to actually measure the month-to-month progress. And it turned out everybody in the payment chain was happy to select camera images. So now the contractor could take the images on site. Everybody could use them to verify progress. And instead of subcontractors waiting 74 days average in the industry to get paid, they're paying subcontractors in full by ACH payments in 2 days on behalf of the banks. And then the story is, well, why don't you become a tech enabled lender yourself? And so what they've done now is they have gotten, leverage from loans that they get from big capital providers, people like BlackRock and others who have, massive chunks of capital to invest. And these construction loans are high interest loans. So it's a long story, but I'm just trying to show how this evolves. And so now
Yeah.
Ko-Fi is now a tech-enabled lender that's doing really well. And, they pre-qualify the loans, they issue the loans, they make one or two payments, and then they sell off the loans so they can recycle the capital. And they make money at every step. They get origination fees for originating the loans, and then they get an interest spread between the money they borrow versus what they lend out. They've had zero defaults to date, so it's like a AAA security that is, paying somewhere around 12 to 15% right now. And so, they're just drawing hand over fist. And so that's the kind of thing that we think can really spread, where you're doing more than just digitizing a paper flow. And now with AI, you just can hardly imagine all the traditional workflows that you can have agentic AI completely automate and take over, maybe with a human in the loop to review it. Ko-Fi still has a human in the loop to review the photos to make sure that the progress really is there, but it takes them 10 or 15 minutes for each payment to just review the photos enough to say, yeah, the progress is real. We should pay this loan.
I can see that, Ray, that that's a great example, by the way, of a company starting with a laser focus on a particular part of that value chain where they feel they have a solution that can add value, and then organically or inorganically, as it were,
No,
expanding into other parts of the value chain. I do wonder, though, whether the creation of all of these relatively small companies, many of which are focused on the software, um, adds a kind of burden in the short term. And, what we've heard over the past decade, many companies talking about is this federation of systems, or the system of systems, if you like. I know that we're a long way away from that at the moment, but how does that change the way you think about some of these software companies, or do you imagine them all eventually expanding laterally or vertically around the value chain?
I think there are two things going on at the same time, Matthew. One is that people like Autodesk and Trimble and Procore and others are expanding the offerings to cover more and more of what, in effect, duplicates some of these point solutions offered by smaller companies. In some cases, they acquire the companies. In other cases, they just, copy the solutions these companies have. But they're
Mm,
often not as good as the really thoughtfully created point solutions. And so we see some companies using a combination of Procore, which actually has a time card solution, but also using Rumbix and paying Rumbix separately for time cards. And so
yeah.
at the moment, we're in a transition period where these companies like Procore, Autodesk, Trimble, and others will eventually have a really good suite of solutions, and it'll be easier for a company and its employees to have a single login to one platform and be able to access all of the different solutions, in one place with a, SSO sign in. And so um, that's going on the one hand. On the other hand, there's some really good point solutions. So part of what's happening is these point solutions are being acquired by these integrators. Another Nemetschek in Europe, which was originally a design company and acquired design companies, is realizing there's a much bigger market in construction because construction contractors generally are bigger and have much more money to dedicate to software than design firms. And so they're starting to buy up, construction tech companies. And so, the multiples are not the sort of thing you see in the AI world where, you have companies worth tens or hundreds of billions, but it could still be an interesting investment for an early stage VC to help a company build up to the point that they have 20 to 30 million in revenue and could be acquired for a few hundred million. We can get a very nice return on our venture money from those kinds of things.
Yeah.
And so I think we're seeing that acquisition is the more likely exit path for the companies we invest in the construction tech space. Some of them, there's one in Germany which is big enough that it might become its own IPO, public company. But they also might sell to a very large real estate developer. So the IPO market has been the initial public offering market to list public companies in the US has been very ineffective and very small in the last few years. So the exits are not really happening that way. They're generally
Hmm.
happening by acquisition by big companies like
Yeah.
Salesforce and in its industry and Autodesk and Trimble and Nemetschek and Procore in our industry. And we can still, we can invest in a company that we believe could get past about 10 million seems to be a threshold for any acquisition. And,
Hmm.
20 to 30 million or more would be for an attractive acquisition, in the hundreds of millions. And so again, we're still optimistic that some of our companies will get there.
Yeah. Ray, we've centered around a conversation, I think, that's largely been based in the software end of the equation. But as you were mentioning with some of the ventures that Blackhorn's invested into a few minutes back, building innovation involves both hardware and software. Um, Clearly, as events have shown, software is an easier sell for VC money because it leads to higher valuations and it's eminently scalable.
Yep.
Um, but clearly, I think from some of the experiences of people that I've worked with in the industry, this feels a little bit like the favored software solution stack the deck against a hardware focused company or solution. And in many ways, perhaps that explains why we have so much in the prop tech space and much less, I guess, in the actual physical production of real objects and things. You mentioned that before about how you split deals to separate out where the VC money goes as to where other perhaps capital intensive money goes. I wonder if you could break that down a little bit more for our audience, in particular about how you'd go about approaching investment into prefab modular MMC or industrialized construction, depending on what term you prefer to use.
Yep. Well, again, our philosophy is it's got to be very capital efficient. So there are two ways you can do that. You can pick just a single trade, as I mentioned before, like assembling rebar cages with robots, spot welding them instead of tying them with wire, which I did in high school. It was the worst job I ever had, and then framing, interior framing instead of people cutting, drilling, and screwing studs and lintels for doors and windows, headers they call them here, for doors and windows. You can prefabricate all the pieces and they can snap together with a patented snap-in connection. That's what Hyperframe does. And so those companies can build a solution that requires about 2 to 3, maybe as much as 5 million of capital to build a complete prefab line. And the idea we have is not that they're going to become a global prefabricator, but that they will perfect a hardware and software tech stack, in a prototype factory. And once they've done that, they'll license it to people who perform that trade. So the rebar company Toggle is already, licensed it to a big rebar provider in Canada, and they're looking at doing an arrangement in Saudi Arabia. They're currently working on the NEOM project, which is one of the world's biggest projects. Even scaled back, it's still very big. And so that then, license revenue is, what companies like Qualcomm use and um, other companies. NVIDIA, is really a chip design company, but they don't make chips. They license their
Mhm.
designs to people that make chips. And so I think you can imagine a prefab company that develops a good hardware software stack that's been ruggedized and generalized a little bit, can then license that to third parties. And so there are big construction manufacturing companies that make materials, which these days have got relatively low margins because they're commoditized. Think of
Mhm.
gypsum drywall, sheetrock we call in the US, or think of um, companies that just make rolled form steel like Semtech in the US. Um, and think of them, instead moving up to a much higher value kit of parts kind of thing that they can get maybe, 20, 30% margins on instead of 5 or 6% margins. And so
Yeah.
those companies would potentially either license it, or you could imagine a private equity firm acquiring one of these companies and then upgrading the skills of companies that do that trade all over the industry. You could imagine a private equity company buying Toggle, the rebar automation company, and then going around to all the rebar um, companies around the country and just tech enabling all of them with this technology and paying licenses to the software companies, and then they have the kind of software margins and scalability that a pure software play would have. So there are a number of ways to think about it, but one of the ways is just to create a prototype that's capital light, perfect it, and then license it to everybody, globally if possible. So Toggle's talking to people in Europe and Japan and Saudi Arabia, to license its technology and has already licensed it in Canada.
Yeah, it's certainly something that we are also interested down here in Australia. I think my experience, Ray, has been that countries that perhaps haven't had a great history or a great depth of manufacturing capability struggle with the kind of investment and long-term patient view that it often requires to get those companies running. And so we've seen an interest down in Australia around this asset light and capital light approach as a way of innovating and building, where it seems that very large format investments in production facilities for now is largely off the table. Is that something you're seeing in the US as well,
Yes,
or are you aware of?
absolutely.
Yeah,
It's radioactive to VCs in the US right now. So
yeah,
even very
yeah,
successful companies are finding it really hard to raise the B round. And we don't do B, we do seed and A. And
yeah,
and a couple of things you mentioned. Yes, it does take a while. It takes about 5 years, we find, to really tune up both the hardware and the software so it's working really reliably and with a positive gross margin. And at that stage, you can begin to scale up. But again, this because of the failure of not just Katerra, but Integra and Vive and a number of other companies that were more capital intensive. This area, just like indoor vertical farming, has become radioactive to VCs. And so Blackhorn has bucked the trend there where we see an opportunity to do it if it's done in a very, very efficient way. And we've also invested in a pure software company that has, I think, a best-in-class solution for managing prefabrication. So it's like a manufacturing management system for specifically designed for construction prefab, which will also link to the projects to make sure that what you're making is actually able to be received on the project. They're not behind schedule in a downtown building with no lay down area to store something where you're going to have to store it yourself because you made it and now they're actually not ready to receive it. And so real-time linkage to the job sites, 3-week look-aheads or whatever detailed schedule they have to make sure that what you're making is actually acceptable by the customer right now. And if it's not, make something else in the meantime that someone else can accept and have a very flexible manufacturing system that can switch over quickly from one type of module to another if you don't make totally standard modules.
yeah. Very important, Ray. What's the name of that
That
company?
company is called Arctic, Artic. Arctic works like, I think they got the name from articulated trucks, and I'm not sure it's the best
Hmm.
name, but that's what they're called. It's a UK
Yeah, well,
UK company.
you're you're in the world of startup names, Ray. So I guess you've been desensitized to names and over the years.
It's
Um,
true.
Ray, yeah, yeah, yeah. There's no shortage of trends in naming of new ventures. So
And if people don't know how to spell it, I called one of my companies Vitae with an accent over the E. And and the French people thought it was vit, which meant fast, and the Norwegians thought it was vitae, which has a meaning in I don't remember what it was in Norwegian, but anyway. But
yeah,
no one knew how to spell
it's
it.
yeah. That's a problem, a bug or a feature.
it
Um,
it's like the research center CIFE, CIFE. No one knows how to pronounce it or spell it.
Yeah, I can attest to that, but as a devotee of the conferences there, I've managed to get my mouth around that one. Ray, let's move to one of the biggest topics that's out there at the moment, AI, and specifically, what does AI mean for building? What is Blackhorn doing in that space? To get us going on this, I want to point back to a thought piece that you guys put out in April 2024 about AI in the building industry in Built Worlds. The piece spelled out several use cases that you guys saw in the building industry. And I'd be keen to test your thinking there a little bit, because I wanted to try the following thesis out on you, and see where I'm wrong and where you see the future going. So if we think about the generative AI as it's become popularized and the large language models, ChatGPT and others, they obviously rely on very large quantities of data to develop these models and then to train them. Obviously, in the world of text-based writing or newspapers or whatever it might be, even financial modeling, this data is ready at hand. Uh, but I would argue that in our industry, in the building industry, we've got a very poor record when it comes to data. Where the data exists, it's sometimes a complex combination of sketches, models, drawings, texts, and it might be drawn from this very large tech stack that we were referring to only a few moments ago. We might even joke that it includes things like whiteboard scheduling and faxes in some cases. So, how do you see AI taking hold in this really data poor and data diverse environment?
So one of the ways that we wrote that piece, by the way, at the Paris Built Worlds, June, is about almost 2 years ago.
Okay.
And the advances in AI since then are just breathtaking. And so
Yeah.
the ability, we've seen a company recently which is using cameras and update video cameras, updating the resolution and the frame speed of the video cameras, where they can ask a question. So if it's a security camera on a job site, they could say, where is the person wearing the um, black hat, with a yellow safety vest on, and the AI will find it. And so, you can use natural language to interface with vision AI, and this person has generated a very big business already in stores to control shoplifting, and also to scan shelves and see where things are stocked out that should be put back on the shelves, just using vision AI and natural language queries. And so the ability to use camera images, you can collect a lot of data very quickly with cameras. We've seen
Hmm.
several companies. The first one, I think, was one of the first ones was a company started by an Israeli woman from Berkeley, which put a camera on the hook of just above or below the hook of a crane. And so it saw everything that the crane was picking up, and then, could help you decide whether you should have more cranes or more concrete trucks. What was the bottleneck in the process, and how efficient was it, and how well was the crane being used, and so on. But now people are using, I mentioned, camera images to verify progress on jobs, camera images to look at quality control. And so you can assemble a lot of data very quickly. And
Hmm.
so the original thesis we had was that the people that had digital data were companies that were early adopters of BIM. So both engineering
Yeah.
companies and construction companies that were using digital models, since the time of mini computers, before they were even available on PCs. People were using software, and having people work two shifts because the software was so expensive. Um, but producing models using software like CATIA that was
Yeah.
on workstations. But in any case, companies that have a lot of digital data can now actually build their own AI, because the technology is so democratized and so easy to use, and it's getting better all the time. There's just a brand new Chinese company that came out today that's making it even easier to ingest all kinds of different data and standardize the format of it, and then begin to be trained on it. And the other thing is that AI can actually generate synthetic data. and then have humans annotate it. And so there are companies using sort of parametric methods to generate huge volumes of synthetic data, have humans annotate it, and then train the AI on it. And so there are lots
Hmm.
of ways that the AI can be used, and whatever's true today will be different tomorrow. But I still
That's a good
see
point.
the large language models are really useful for searching project documents. So if you just scan in all of the PDFs and all of the blueprints and all of the RFIs and change orders and so on a project, you could ask a question about, give me everything that's relevant to this boiler or this chiller or this um, beam column connection. And, the AI will find it and give it to you. So that's an obvious thing that anybody could do on any job site without a software company having to do it for them. And so
Mm.
for software companies, I think they either have to make tools like the one I just mentioned that just came out from China, that makes it easy for people to ingest a lot of different data and develop their own AI workflows, especially for people that have a lot of their own digital data already or who can collect it through cameras and by analyzing emails and text messages. You've probably seen the tools for summarizing phone calls like this that would actually produce a very
Yeah.
concise summary for us. Maybe you're using one of those tools. We use something called Fathom, which does a really good job of summarizing the key points from a meeting.
Hmm.
And um, so really two things. Companies that have a lot of digital data can build their own AI using off-the-shelf tools available from all the cloud providers and others. And companies could build tools that make it easy for contractors to develop, their own AI solutions with their own data. And there are, you can scan old paper drawings. You can have vision AI that can identify documents or objects on schematic drawings. If it's a public, if it's a piping and instrumentation diagram that uses squares and triangles and hexagons and so on. It can look at all those images and know what they are and actually learn from them. And so I think we actually have a lot of data in construction, but as you say, most people don't really have access to, they've never organized
Mm.
that data. So what we recommend is construction companies should hire their own data people who know how to create data architectures and assemble the data that they do have, whether it's historically digital or not, and begin to do it going forward, and then build AI solutions by hiring people, who know how to do it. And it's easy to get those people out of universities now. And if you have
Yeah.
good data, you can train your own AI on your own data. And again, I don't see and I see a lot of Me Too companies that are now using large language models to scan project documents. And, that's easy. That's sort of going to be low margin because it's such a crowded space. But doing more interesting things with AI, like watching how humans do tasks and then training robots to do it from that. There are companies doing those kinds of things. Um,
So I think, Ray, it's fair to say that you're definitely an AI optimist as it pertains to
well,
building.
but
A
not
fair
not
assumption?
necessarily for startups because it's so easy for companies to build their own solutions.
Mm.
So I'm an optimist for people that are studying data science right now and AI. To get jobs with companies that have digital data to build their own in-house solutions. And we find that a lot of the companies in our portfolio are adding AI to what they already have. So for better searching documents or so-called agentic AI, where the AI not
Yeah.
only reasons about some problem, but actually executes a task without human intervention. And this Chinese company actually just built a system that can create multiple AI agents with specialized capabilities, collaborating to solve a teamwork problem and kind of managing them. It's amazing. So
Which company is that one, Ray?
I'll have to look it up for you.
Well, yeah, we'll get that in the show notes after the fact.
Okay.
Um, yeah, look, really interesting. I mean, and what a fast development as well. I mean, when we think we've only Chat GPT, as the first really popular generative AI to come out was only really 2 years ago.
And
And so this entire change,
they trained it on the internet, so they got a lot of junk in there, and so you get these hallucinations as long as
yeah,
the AI doesn't realize that it's stupid for Knights of the Round Table to include women and black knights, stuff like that.
yeah,
But
yeah,
I don't think that the newer systems will do that. And Deep DeepSeek really changed the game by allowing you to build AI models with much less data, much more efficiently, and run more efficiently with less computer hardware. And then this company I just mentioned with the managing multi-agent AI systems, it just gets easier and easier to build these yourself. And so can a company build a generic one? Companies like Autodesk have tried to get general contractors to share all their data on past projects. And again, you have to annotate the data. Was the project successful or not? And that's very time consuming, and construction companies are very reluctant to share that data to go into a solution
yeah,
for their competitors to use.
of
So we're
course.
being
Yeah.
pretty cautious about people that are saying we're building an AI solution to do X because we think companies with data can do it very easily themselves.
Ray, one of the things that jumped out at me that appeared low-hanging fruit, but I haven't seen a company working in this space yet, is really around building codes and regulations. That is a place where large amounts of textual data exists
Yes.
around building. It is something that causes immense headaches for companies operating in the space. Are you aware of any ventures working in that space?
Yes, I'm aware of several. First of all, there's a
Okay.
company that accumulates all the different building codes in the US. By the way, there are thousands of them. We have a national building code, but every city, village, hamlet, has its own tweak on that building code. So you really need all the
Correct.
building codes to have a nationwide solution. But that's just the data, of what the building codes say. And by the way, some of what codes say is internally inconsistent. One part of the code says A and the other part says not A or B. But what we've seen companies do is automatically look at what the building codes and other regulations like national environmental protection laws and so on require in terms of the complexity of permitting and both getting a use permit but also a building code and then automatically checking against codes. And so that is a great solution. And there are companies that are doing various versions of that. Solibri, which is now owned by Nemetschek, was an early one. It actually spun out of one of my early companies, Design Power. Um, and so that, they can check against codes, they can check against company best practices. Um, and so I think automatically checking models against codes is a very good application. It would probably mostly be used by design firms, but
Yeah.
maybe by general contractors in reviewing subcontractor submissions. And the thing with design firms is they generally don't have a very large budget for software.
Yes, that's right. And one of the other places that we're aware that it's of great interest is with those regulators, with the approving bodies, the municipalities or state governments, as it were, who are charged with assessing complying developments and things of that nature. So a space that I think we'll see a lot of activity in years to come.
Just one
Ray,
thing in
yeah,
that area that
sure.
I'll mention. There's a company in the U.S. called Symbium, Symbium. What Symbium does is they automatically issue building permits on behalf of cities for simple things like, insulation in the walls, solar panels on the
Hmm.
roof, heat pump replacing a furnace. And so the city finds that just overwhelms their code checkers. So they have actually empowered this company to issue building codes on behalf of the city, and they get paid for each building code they issue, each permit that they issue.
Wonderful. Wonderful. Yeah, a really key part of the puzzle that needs to be resolved and fixed up in years to come. Ray, I want to move to wrap up now. It's been a fascinating discussion for me. Um, One of the things that I most admire about you is the length and breadth and depth of your knowledge of this industry, this hulking and sometimes crazy industry that we call the building industry. I wanted to ask you, what do you think we should focus more on in the building industry? Or another way to ask that question is, what do you think is not getting enough attention?
There are so many startups attacking so many different kinds of problems, but I think with the growing labor shortage, the ability to use robots on site has still been a real challenge. There's some examples of robots used on site for painting, for plastering, for some people even created a bricklaying robot that I think is silly because a robot could pick up a much bigger brick than a human can. It's not clear you'd
I
use
tend to agree with that
a
one.
robot to mix mortar and stick it on bricks and paste them down, although somebody did that. But many of the tasks, I think the prefabrication will be done offsite, and the modules will be mostly 2D because you can flat pack them and ship them efficiently longer distances than modular prefabrication, where you've got volumetric units that are shipping a lot of air when you put them on a truck or a train or a ship. And so we're seeing wall panels being made in Poland, facades, aluminum glass facades for
Mhm.
buildings being made in Poland and shipped to the east coast of the US economically, arbitraging the wage differences and the experience of prefab in Poland. Um, but I think we'll see a lot more of these 2D panelized systems being prefabricated. And again,
Mhm.
I think we'll see more of the single trade prefabrication, like I mentioned, for rebar and interior framing. And I think the business models will be, either big companies figuring out how to do this themselves or buying startups that have developed good solutions and then, either buying the startup or licensing the technology from the startup. And so I'm still bullish on capital efficient prefab just because of all the tailwinds for it. And I think also there could be more done in just the money flows in construction. We've invested in one
Mhm.
company that actually issues bonds on behalf of small municipalities that are doing projects or local districts like a local water district or sewer district. And traditionally, those bonds had to be done through bond underwriters that, would charge 6% for doing it and wouldn't be able to do small bonds. It just didn't make sense. And so they're doing it on a blockchain, and now they've become a trading agent where they can trade these bonds, turn them into assets that can be traded. And so the financing of construction, I think, can be digitized, using technologies like blockchain, and then you could bring a lot of AI into the underwriting. And I think we'll see AI being used to make robots smarter so they can work around people and around messy job sites more safely. One of the areas where I've not seen enough investment is in augmented reality when the headsets get to the
Mhm.
point where you're not looking at a low resolution camera image of your surroundings, but you're actually looking at your surroundings and you're still seeing projected in, something like the eyeglasses that I'm wearing, of something with that form factor that actually provides a lot of useful context information on what you're looking at, including, for example, um, documents, warranties, vendor information, IoT data from equipment that you're maintaining or working on. But you're actually looking at the real thing with the resolution of
Mhm.
your retina in your eye rather than, a camera 640 by 760 resolution or whatever you can get in a current extended reality device. So I think there's a lot of good applications for that once the hardware gets just a little bit better developed. It won't take long. I think also edge processing is, I know we're over time. The other one, edge processing of AI instead of uploading a lot of data to the cloud, especially images and things that have, a high cost of uploading and downloading.
Yeah, very interesting, Ray. And I want to make sure I get this right. The maxim before whatever is true today will be false tomorrow. Is that right?
With AI, it's going so fast, it's literally breathtaking. My three startups, two of them were early AI applications for automated design. of semi-custom things like refineries and data centers and so on. But the new AI is so much more powerful. I can imagine all kinds of designs being done and companies' style grammar being copied if they were architects and engineers. It's a very exciting time. I'm sort of getting towards the end of my career as a venture capital person. I think it would still be exciting. Venture capital was basically designed around software. It works really well for software. You have to be a little bit of a maverick like us to go into hardware with it. But I think there are ways to do it. So it's been a fun time, but I think the future is about AI and what you can do with AI to make the industry better, safer, and more fun to work in.
Well, Ray, I think that's a great place to leave it. It's been absolutely fascinating to pick your brains about these things and the trends and what you see coming down the pipeline at us. Thanks again for your time today, Ray. As always, notes and references that we've discussed today will be added to the online show notes. I want to thank our audience for listening, and I also want to thank you, Ray, for what's been a fantastic, eye-opening conversation for me. Thank you.
Thank you, Mathew. I enjoyed it.